Hi. Hi, everyone. Thanks for being here today. First off, I want to thank the organizers of this amazing conference. It's been awesome. I've met a couple of people, and wow. And thanks for inviting me as well, to call SAC and all the sponsors. Thank you very much. And it's my first time in Wrocław. The city is really beautiful, and I'm excited to be here. I'm excited to have all of you here with me. So we're going to be talking about offline strategies in React Native. But then the concepts I'm going to talk about today are not limited to React Native. It can be applied to React as well. Okay, so let's get started. So a little bit about me. My name is Chiamaka Nwolisa. You can call me Chi, everyone does. I'm originally from Nigeria, but I live and work in Ghana. I'm a front-end engineer at M-Pharma. M-Pharma is a health tech company headquartered in Ghana, and we're on a mission to provide quality health care and affordable medicine to everyone in Africa. And you can check out some of my works on the interwebs. I like to make content about React, React Native, and other web technologies. So why does offline matter? Why are we even here? Why am I talking about this today? So I'm going to drop 3 facts. First one is offline improves user experience. The second is improved user experience improves retention, which is what we all want in our applications. And the third is improved retention is good for business. So in summary, offline is good for business. And one of the fallacies of distributed computing is that the network is always reliable. And we developers, we tend to think this sometimes because we build in controlled environments where the network is usually very great. We build with the fastest and the best machines, and we test with the best devices. But the reality is that the network speed on our users' devices vary greatly. And the fundamental premise for building mobile apps is to give users the ability to access information on the go. And when they're on the go, they're in a constant state of flux between great connectivity and zero connectivity. So it's our responsibility to make sure that our apps just work. So according to Think Small Cell, approximately 45% of all connected devices have connection speeds lower or equals to 2 megabits per second. Now, that's a very abstract concept. So let's put it into context. Let's download a 14 megabyte file on a 2 megabit per second connection speed and see how long that takes. Well, we're halfway there. Almost. Okay, we're done. That took about 43 seconds. And I don't know about you, but that was painful for me, seeing as I'm standing up here alone. And the thing is, some websites are actually larger than this, so you can imagine what some users go through. And it's much easier to build an app with the assumption that the device is always connected to the internet, right? And offline-first apps require going beyond the app just working. So it's very easy to overlook. So with this talk, I'm going to be talking about my learnings on converting my online-only apps to offline-first apps. So the first thing I always tackle is data. Data is the lifeblood of any application. And for your app to be able to work offline, we have to persist data in some way, ergo caching. But then it's not just about caching. Storing data is relatively easy. There are different mediums you can employ to store data locally in React Native. There's async storage, there's SQLite, there's Realm, there's Watermelon DB, there's PouchDB, there's Couchbase Lite, and the list goes on and on and on. But the real problem is cache invalidation. Now, cache invalidation strategies vary from use case to use case. And for mobile apps, most cache invalidation strategies or techniques can be handled by timestamping. So if you think about it, when you get data on your device, it's only valid for a limited amount of time. For example, if you're reading a Medium article on your phone, we can assume that the article is going to be valid for, let's say, the next 10 minutes or 20 minutes, or even days. So it means once a post comes, it can be saved as is. So when you get data from the server, you save it on the device with the timestamp with when it was last created or updated. And this is really key because it gives you the ability to be able to determine how long you want your data to be valid for on the fly. And all you have to do is check if the current time is X minutes more than when it was saved, where X is the absolute validity interval, which is the predicted period of time that you have determined before your data becomes stale. And also, a good rule of thumb is never delete cache, instead overwrite it. It's usually better to show stale data with information on how long it's been stale for than to show nothing at all. And yeah, you should be careful about how you implement this in critical systems like health or financial applications. You don't want people coming at you that you've lost their money. Now, once you've figured out your cache invalidation strategy, you can employ what I call the repository pattern to fetch data. Now, this is how it works. It's a simple waterfall model that fetches the most recent valid data from the fastest source. Here, we have 3 repositories: the memory, the disk, and the network. And we have data in each repository. And depending on the validity of the data in each repository, we return that to the application. The first level is memory. It is the fastest data source and is the most volatile. And when you check memory and the data in there is valid, we can return that to the UI. And if it's not valid, we go to the next data source, which is the disk. Now, if the data in the disk is valid, we return that to memory, save it on memory before returning it to the UI. But if it is not valid, if the data on the disk is not valid, at this point, we can check if the app has an active internet connection. If there is no internet connection, then we have no choice but to return the stale data as is. But if there is, then we can go over the network, get the results, return it to disk first, persist it, very important. Then from the disk, we return it to the memory, save it in the memory before returning it to the app. Now, this pattern is very good for when your app goes into the background and is killed by the OS. So when your app comes back and is in an offline state, the data that was saved on the disk can be rehydrated instead of going over the network. So you don't really have to rely on the network. And you can implement this pattern for getting data in your offline first applications. Now, next thing we're going to talk about is UI UX. So to give your users the best overall experience, communication is very important. Very frustrating experiences in applications can be avoided with simple communication. Something like notifying your user when the app detects that the internet connection is unavailable. That would help your users manage their expectations. And when a user knows that the unexpected behavior that was caused by the internet connection, they will not feel as though it's a bug in your application. So simply keeping our users in the loop can go a long way in making the experience of our apps enjoyable. Now, there are apps that do this well out there. Gmail is an app that I love to use. It has offline capabilities. And even when I'm in a state of zero connectivity, I still have access to very important information. So when I load the app in offline mode, it shows me a nice no connection sign. It's small, but it lets me know immediately that it's not everything online that I'll have access to when I'm offline, and it helps me manage my expectations. Another app that I really love is the Coursera mobile app. We'll talk about something that they do particularly well later, but for now, I want us to focus on the wording. They just have a simple word, like a simple thing that says you are using Coursera offline. That goes a long way. If you see this and you're using the application, you immediately know that it's not everything online, so you can't access all the courses, but then you have some things that you have saved for offline. And the same thing goes for YouTube as well. These are all different ways of communicating with the user and telling them what is going on. And this is not something that's really difficult to do, right? React Native provides us with the NetInfo API that basically allows us to get network information in our apps. So what we can do is, based on whether there's an internet connection or not, we can show different messages and appropriate messages to communicate with our users. And all we have to do is listen for connection changes and do whatever we want, such as show a snack bar or help our users navigate the app in offline mode. Sorry. Now we've handled data and adapting the layout. Now let's think of our applications in two categories: read-intensive applications and write-intensive applications. Read-intensive apps are apps that only consume and beautifully display data. So we get data from the server and display it in the app for our users to consume. On the other hand, write-intensive applications are apps that allow consuming and creation of resources. So we give our users the ability to create new resources, edit existing resources, and delete resources. And these are all write actions. So if we're catering for offline usage and our application is write intensive, we have to think of something else. A way to make sure that we still have access to the resources that the user has created whilst they were offline, whilst they were being cut off from the internet. And that will lead us into syncing. So data syncing is a very broad subject, and there are way too many to discuss today. But syncing implementations are severely dependent on things like your data model complexity, or the amount of data you want stored and transferred, amongst other things. But I want to talk about some of the things that I have learned personally. One of the best databases for building distributed applications today is CouchDB. Has anyone ever heard of CouchDB? Cool. And it's because of its synchronization pattern. So it uses what it calls the replication protocol to sync JSON documents between two pairs. So two pairs could be client and server, server and server, client and client. And if you're a JavaScript developer, which I think most of us here are, you've probably used CouchDB because it's the core technology that powers NPM. Then there's PouchDB or Couchbase Lite, which brings the CouchDB API to the client. So out of the box, with CouchDB and PouchDB or Couchbase Lite, you can create a write-intensive application with syncing abilities. But this isn't always the appropriate fit. Imagine a scenario where you already have your infrastructure in place, which might consist of like various microservices, and they use Postgres as their database and blah, blah, blah. And you can't really afford to restructure your infrastructure to fit CouchDB. What do you do then? Then we have to handle our own synchronizations. One way is to have a change log or a delta log, where every change in your application is saved. So an incremental or delta sync is one that only processes the data records that have changed since the last time the sync was run, as opposed to processing the entire data set every time. And this can be a good choice for you because by limiting the number of records being processed to only what has changed, it allows the integration to run more quickly and efficiently, which in turn allows it to run more frequently to keep all systems up to date. So when the app has connectivity, we upload all our changes to be reconciled with the server. And a very important thing to note is that failures would happen. So plan for failures. Make failures a first-class citizen. So for failures, we can use the exponential back-off retry method and retry the failed operation at a later time, because there are different reasons why a sync would fail. And the thing is, Trello uses this under the hood. If you know, Trello mobile app is offline first, so you can use it fluently without internet connection. It uses this sync strategy, and also Redux Offline, created by Yanni. Yanni is not here. Uses this under the hood as well. Now, as a business, you can give your users added value by leveraging some offline capabilities. And a simple offline technique will be to offer your users a way to download your content for offline use. So let me tell you a story about this app I was working on. It's a radio app, and it allows you to listen to your favorite radio shows. And we also record the live shows so that in case you missed it, you can always play it back. So we had feedback from one of our users, and she said, the playback for a certain radio station takes forever to play, and there are breaks in between the recording or the streaming. If it's a playback, there shouldn't be any breaks as though it were being live streamed. This is exactly how with the emojis and all that. So when we received this feedback, we thought about a way to solve this problem. And we decided to leverage the download for offline capability to improve the experience of the application. So what we did was we gave our users the ability to download the playback, which is the recorded live show, and let them listen to it buffer-free. And with this feature, we're able to cater to our users' varying connection speeds and also give them the flexibility to listen to the playbacks when they had no internet connection. So on the left is the screenshot for downloading it, and on the right is when you're offline. You have access to all the shows, and you have access to the playbacks as well. And offering your users a way to download for offline use is not really a new concept. It's nothing novel. There are a plethora of apps that do this out there, and there are companies who actually do this today. There's Apple Music, there's Netflix, there's Castbox, there's Coursera, there's Spotify for people who don't really like Apple Music, there's YouTube, and the list goes on and on. Because with this feature alone, you can create a great offline experience for your users. So we've talked about a lot of things. We talked about data, we talked about UI, UX, we've talked about offering your users a way to download for offline use. Now I want to talk about images. Images are a very important component of any application. And they add much needed context and visual flair to all our apps. But how do we include images in our offline applications? One way is to load all the images locally into the app, but that would increase our app size significantly, so no. Another thing we can do is, to reduce the app size, we can reduce the image files, without compromising quality, but it's still not good enough. Okay, an alternative is to put the image on a CDN somewhere and remotely access it. That will work when the user has an internet connection. But we don't want to stop there. We want the images to be able to show up when the app is offline as well. So to do this, you can use a caching library. You can use any caching library out there. So for Android, we have Glide or Picasso. For iOS, we have SD Web Image, we have HG Cache, and we have JM Image Cache. But for React Native, there is a fantastic project called React Native Fast Image, created by Dylan Van, that wraps around Glide for Android and SD Web Image for iOS to help you get remote images and cache them without breaking a sweat. And it's also a drop-in replacement for the image component that comes bundled with React Native. So you can leverage this to cache images in your applications. So, as we wrap up, here are a few principles that I'd like for you to remember. first one is to communicate with your users. Your users are the focal point. They are the main reason why we are here today, why we build applications. And making sure that they have a fantastic experience is of utmost paramount importance. It's very, very important. The second one is use local data whenever possible. So because we are treating the network as a progressive enhancement, we're basically cutting off our application from the network and saying, we want our app to work whether there's an internet connection or not. And using local data whenever possible, if there's no internet connection, your users can still access important information on their devices. And the third one is offer a way to download for offline use. There are a lot of apps that do this, like I said before. And it's not that simple, to be honest, but with this feature alone, you can create a fantastic offline experience for your users. So when building for offline, take the time to think about what the most useful offline experience is for your users, because every app is different. I have built 3 offline applications, and every time there's always something different in all of them. So please take the time to think about what the most useful experience will be for your users. Well, I've come to the end of my talk. Thank you very much.